Okay, so this is our second most missed question. This gives us a second derivative, and it just gives us the function for the second derivative. And it asks us how many points of inflection the original function f has on the interval from 0 to 3. So we're calculator active on this part, so I'm going to go straight to my calculator. All right, I'm going to go ahead to y equals. I'm going to make sure I'm in function mode, and I'm going to type the function in, so I have that in there. All right, this is the second derivative, so I'm looking for when this one changes from negative to positive or positive to negative, because that's going to be a place where there's a change from concave up to concave down or vice versa. Now, since I'm only concerned about that change in sign, I'm going to actually narrow what I look at pretty substantially. So for the x, I'm only going to go from 0 to 3, all right, because those are the only ones that matter because that's the interval we're looking at. Now, for y, a lot of times people leave this as negative 10 to 10, just because it's the standard view. I'm only looking for sign changes, so I'm going to actually shrink that down a lot more, and I'm going to show you why real quick. If I go negative 10 to 10, and I hit graph, all right, it is very hard for me to tell at least one of these, that first spot where it looks like it may touch the axis, what's really going on. But if I adjust my view window just a little bit in y min and max, and I say, you know what, I'm only caring if it goes from negative to positive, and maybe go like a negative 0.5 to a 0.5, this is going to bring a lot of clarity. All right, so now I go here, and I've got this graph. It's very clear. I've got one spot here, one spot here, one spot here, one here, and one here. So 1, 2, 3, 4, 5. 5 spots where the second derivative changes from positive to negative, and the second derivative equals 0 or is undefined. So that would be our correct answer for number 78. Hope that helps.